If you're on the onboarding call, you could recall that we mentioned that there will be elimination and everyone participating in the bootcamp have to really get involved. So today you'll be receiving an email. That's to every student on the call. You'll be receiving an email, and that email will contain certain criteria which we are looking out for as a community, and why you have to be really serious on the bootcamp, because we want to really work with serious hands, and we want persons to be very committed. So, and part of the criteria will be attendance of classes, commitment to assessment, and so on. So, if we find out that at some point you're not really following up, I'm afraid to tell you that we might be dropping certain persons at some point. So you have to give it your really best. You have to put in every effort that is required of you. Though I know that this week it's still very, very basic. We are trying to build up from foundation. So just try to follow up. We have the sub mentors. At any point where you are stuck on the Discord channel, you could always request for help. We have a help channel where you could also always put up your challenges or obstacles or whatever you're experiencing, be it bugs or so on. And the sub mentors are there to guide you. So you're not alone, that's it. But we want you to be committed to the bootcamp, and we want to really work with serious hands. So this is just to re-emphasize to everyone that there would be elimination. Yes, some people will be dropped off during the course of the bootcamp if you are not serious. But if you're serious, you attend classes, you do your assessments and do project and so on, then you're on a safe space. So there's no need to get scared. There's no need to be scared or afraid of anything. Just ensure that you're serious and you attend most of the classes. Yes, we want students to also be on the live classes. But for any reason you're not on the live class, then ensure that you're also active on the Discord. We are tracking activity of students on the Discord channel, on the WhatsApp community, but majorly for this bootcamp purpose, we are using the Discord channel. So ensure that you are really very active. We are watching out for that so that you don't fall on the elimination list or so on. So I'll be passing more information later on, and you'll be receiving a mail that contains every information. All right, so Manoah is on the call. I think I'll stop here. Let me not talk so much. All right, good morning, Manu. You, morning.
Yeah, let me unmute my mic. Good morning, everyone. I trust everyone can hear me and you're having a good day. My network is kind of shitty this morning, so I've been battling on joining the call. I've been on the call for like 5 minutes before my UI was visible. So I can't turn on my camera or my mic, but now I'm good to go. And probably for the course of that, I'll be offing my camera today, and then so that I will manage my bandwidth. All right. So how do we do? How is everyone? We don't have now. We have just half of the call now. The last class we were 50 on this call, and today we are 26. So that either means that a high percentage of the class, or 50% of the class, usually comes late. So let me just have a glance through of the names that are here, because the people that come late are the people that usually come up with a lot of questions, simply because they were not early to class. But let me see the early comers. All right, great. So last week, 2 days ago, we started a quick introduction on the blockchain technology, understanding what it is, understanding what Web3 is, the new technology we want to go into, and a lot of discussions though about what the technology really is to build us like you are. And then, like I said, I'm going to be assuming that most of you or everyone is a newbie to the ecosystem. So I will not be talking on very much technical terms. And then from then, I gave you guys few resources to have a look at so that we can have a proper discussion today on what you understand the blockchain technology to be thus far, in your own understanding. So with this piece of information, we can be able to move on so that we know whether you understand the entry point or not. All right. So the floor is going to be for you guys, I think for the next about 30 minutes. So by 9:39, we should take the mic off you guys and then the class is going to start officially. But for now, I really need to know how you have gone thus far. So the floor is for everyone that wants to talk. 2 minutes, 3 minutes should be enough time. And then I want as much of you guys to talk, because most of the names I'm seeing here are 100% sure that you were in class the last time.
Good morning, sir. Good morning.
Good morning, Tech Explorer.
Actually, what I read when I was like trying to read about blockchain, then I saw something came into the glimpse. They say before you understand blockchain, you have to understand the distributed systems. And the distributed systems, they are computing pilgrims, whereby two or more nodes work with each other in a coordinated fashion to achieve a common outcome. And in there, they try to explain the how the blockchain is connected to the distributed system, whereby they call it a distributed ledger, which can be
Yeah.
centralized or decentralized. But actually, it's decentralized, but they made it centralized in a way. And also, I learned about the nodes, whereby they say the nodes there are multiple, like in the main side, there are multiple, but in the end user side, there are one. So that's what I grasped. And I also get to know when blockchain actually came out. Like it first came to a glimpse 2008 and was first publicized in 2009. That is when the issue of Bitcoin began. 2013 it was. So I'm still reading on.
Okay, Tech Explorer, I like that. You are truly a Tech Explorer, right? I like the way you likened it to distributed systems. So like I told you guys, the blockchain technology or Web3 in itself is not just something that started one day. You will understand that there are a lot of concepts that originated from years. A lot of things that happened before, and then the system is being brought together to we having Web3 today. So it's interesting. And then one of which you mentioned is distributed systems, right? This is not a new concept. It has been existing since. It has been existing. But then the blockchain copied from that concept, or Web3 copied from that concept. Who's next? And the ladies, just know that there has to be equal representation, right? On the call, so that we don't have to do justice for women later or justice for Natasha. So let's proceed. The floor is yours. Jethro, just unmute your mic if you want to talk.
Okay, everyone. I made research on consensus mechanisms to reduce sluggish because in the last class I was battling with how it all works and thereabouts. But I went and did research, and then I saw that we have different types of consensus mechanism. which the proof of work is one and proof of stake is another. And then the proof of work was predominantly done during Bitcoin's era, where computational power was what determined the transaction or how someone mines to earn. After mining, how he earns through proof of work, whereby the different nodes, the reward comes through the degree of fastness or how your CPU works. That is how you earn. So, for example, if your system is a bit slow, you will not earn. But if your system is fast, you will earn. And then transition came, and then Ethereum emerged, and it's basically solved the issue of that computational power, whereby stakes are what we use now instead of those nodes, whereby a user or someone who wants to transact, we just um, stake a certain amount of it, so that it will give you the ability to now mine on Ethereum blockchain. So I particularly went to study about the key difference between Bitcoin and then Ethereum, and from my understanding, I think that's the major difference. And Ethereum allows decentralized applications to be built on it more than that of Bitcoin. So I think that's what I just noted and decided to share. Thank you.
Yeah, interesting. Interesting that you went deep to understand a little more about the consensus mechanism. And then you highlighted the two that we are going to be discussing about today: proof of work, proof of stake, and then noted a few differences between Bitcoin and Ethereum, right? Okay, that makes sense. So in the course of the class, we are going to understand these concepts properly. For those of you that didn't read from this angle, you get. So who's next? So we should take a lady this time around. All right, then anyone can just talk. The floor is open. No, we can't take only two people, except you can't hear me. Yeah, let's go. Shoot.
Okay, GMDM. I read on blockchain mechanism, how it works. So I found out that blockchain, as the name implies, is a series of interconnected blocks. Majorly, they are used for storing data, not necessarily transactions. Because we look at the application of blockchain, it's used to store transactions. That's why we mostly use it in finance. It also can be used to store NFT. Also using basically storing of data or information. So, and I learned that before a blockchain has what they call block head and hash values or block values. The block values are actually the data stored in the blockchains. So the block header is basically just when a new block is initiated, the block value of the previous block is used as block header. So as to link the previous data to the existing block to avoid altering. Because if something like that is done, for you to alter the new block initiated, you have to alter the many blocks. So, and also there's each block has its own storage capacity, 1 MB. Now that is also used to used to avoid being altering to alter the block itself. 1 MB data storage units. And the process of securing blockchain is what they call cryptography. And cryptography and hashing is one of the way of securing blockchain. Just hashing is just like um how do I say, it's just like putting any amount of data information and transforming it into an output of fixed data unit. The example I come across is like normal our Facebook server, all these other this thing. The server didn't store our name or password as the way it is inputted. It is hashing algorithm. That hashing now give an fixed output which the server stored. So whenever you input our password or this thing, it checks if the password correlated with the output it's giving. So basically, hashing is a way of securing our blockchain. And also, I learned about 51% attack. This is a way in which if more than 51% of the blockchain can be manipulated, then there's probability of altering the blockchain. And there's also what they call Byzantine general resistance. It's a way of just or what will I say? It's a collision resistance, whereby in hatching you can when a data blockchain is being hatched is hatched, there's always an output, a fixed output data unit. So if there's probability of having more than one output fixed units, that's what they call collision. And Byzantine general rules used to prevent that. So and so on and so. I think.
Interesting. Yeah, so I like the fact that you also went deep to understand a few concepts about how the blockchain really works. Yeah, so we'll get a lot of clarity today while we move in the class. Yeah, so Akanimo, let's get you.
Okay. So good morning, everyone. Can you hear me?
Yes, sir.
Okay. I went deeply also on the blockchain and the Ethereum paper based on just like how Jetro highlighted about the POA and POS, which is proof of work, proof of stake. So I just want to highlight a few things also I learned about that. Is all about miners and validators. And these miners could be a node, which is the proof of which is the POW, which is proof of work, which he said you need to have a high compute power, which Ethereum solved that for us. So instead of having a high computational power, maybe you could not afford those high intensive computers. He then brought about the proof of stake, which you can use, for example, your ETH to stake to also be a validator. So in some blockchains also, I learned that it could be called validators or miners. So what are these validators? What they do is they solve most of the complex puzzles to add new blocks. So just like the name implies, blockchain, so is a two word, which is block and a chain. So the block is just the page that records the data. So we say each of those blocks can contain transactions, which is in the transaction, we have a hash that is just like a number, series of numbers that could link the previous block and the current block. So the chain, we say the chain act as a finger depends on previous block. And if someone tries to change the old block, you cannot alter anything once a transaction is being approved by the validators or the miners. So that's what I have to contribute. Thank you.
Okay, interesting. You also went to understand about mechanism, how the blockchain works. Yeah, more feedbacks. It's not 9:30 yet, or 9:39, sorry. So we still have time. Yup. Melvin, shoot.
GM everyone.
GM Melvin, but I can't seem to hear you. What's wrong?
Okay, can you hear me now?
Yeah, proper.
Okay. One of the things I learned is the distributed ledger and transparency in blockchain. So transparency by which every transaction is being recorded and is being public with timestamp. So anybody does anything can be seen, which can't be altered. That's bringing in trust to the blockchain. And for the distributed ledger, which entails of your transactions being stored on different nodes. So if a node gets hacked or it crashes, you still know that you can recover your data despite even though it's one node again that's running, your data can still be restored due to the distribution of data across multiple nodes. Thank you.
Okay, awesome. No lady have spoken yet. That's serious. So more feedbacks about what you've read, please. And it can be anybody. Okay, just type it in the chat if you don't want to say, yeah, Latifa, just type it in the chat. That was exactly what I was about to say. So that means most of you people didn't read, or didn't read. So the class today will be kind of shallow. And I'll try not to give out as much information as possible. Because only a few amount of people understand what I'm saying, except most of you don't want to talk, which is allowed for you to type in the chat currently. So you have a few minutes to prove to me that you really read. Just type whatsoever you want to say on the chat. All right. So since we don't have much feedbacks, I hope you all can see my screen. And I'm allowed to proceed. So today's class, there will be no slides. It's just going to be we trying to go in depth into what we studied the last 2 days. So last 2 days was more of an introduction, while today we are going to go deeply into how the blockchain works. So let's really understand it. Let's understand this Web3 under the hood, what really happens. we said we are no longer working with one central servers. So now we are working with different servers or multiple servers, which are called nodes in different locations. So let's understand how it really works under the hood. Yeah, Tech Explorer, you have? I can see your hands up. Oh, okay. All right, so that's what we'll be doing today. Understanding how it truly works. So let's know whether this technology is going to be possible or not, because the last class we said Web3 is still under construction, right? And it's not yet fully ready. So the world, we are still working on Web2, and that's what we are using currently. That's a stable version of the internet that we are working with, Web2. And that's what everybody understands. But this Web3 that is coming, we need to understand the technology behind it, how it truly works, so that we'll know whether it's going to work or not. If it's not going to work, let's just continue our career as Web2 developers. Because I really tell people most of the time in my class that what's the essence of learning Web3 if you don't know that the technology is truly going to work, right? If it's not going to work, why are you going to bet your whole career on it? This is your career we're talking about now, not just you wanting to go into something. It's your career. So instead of you just jumping into the Web3, let's know from the mechanisms whether it's really going to work. And then you decide by your own self. If your instinct tells you this technology is not going to work, decentralization is not going to be possible, then you just continue as a Web2 developer. Because trust me, there are even Web3 developers today that still don't believe in the technology, that don't believe whether it's going to work or not. And big people in the game that say decentralization is just a myth. But let's understand the technology, then you will justify by yourself whether it's going to work or not. That's just what we are going to be doing today. Okay. So if you ask me, the best way to start understanding the blockchain as a developer is you know, there are different blockchains, right? Like I explained last time in the class. And you all must have heard of plenty blockchains, ranging from different layer 1s to layer 2s. Ethereum, Bitcoin, Starknet, Leaks, Zion, what else? And the rest of them, right? But if you ask me, the best way to start exploring the blockchain technology as a builder is starting from Ethereum blockchain. So why did I choose Ethereum, or why did I pick Ethereum? There are a few reasons why. If you are going into the technology as maybe a lover of cryptocurrency or someone who wants to hold crypto that might be life-changing, I would say you start from Bitcoin, right? Because those are the core reasons behind Bitcoin, strictly about finance. But if you are coming into the space as a builder, I will really recommend you start from Ethereum. Ethereum is a layer 1. And then Ethereum is the first blockchain that introduced programmable apps on it, on the blockchain. Yeah. So this is it. Initially, Bitcoin was just for you to make monetary or financial transactions. That's me sending 1 Bitcoin to Emerson, and then Emerson sending 0.5 Bitcoin to Lizzie, or Lizzie sending 0.2 Bitcoin to Melvin, right? That's just the idea of how Bitcoin was built, just to fix finance, right? Financial problems, inflation, and the rest of them. For those of you who have already gone into the Wiser app, you are going to be understanding what I will be saying much more better. Yeah. So I didn't get input from most of you about Wiser. Now, Wiser is very important. Now, this is the simple reason why I gave you Wiser to read. Is because Wiser teaches you a lot about Bitcoin. Yeah. And this is a simple reason. Bitcoin is really the grandfather of this whole technology, right? I was in a Twitter space, I think, was it yesterday? Yeah, yesterday or day before yesterday with Vitalik on space. And then Vitalik is the founder of Ethereum, right? Like we all know. And then Vitalik was a builder on Bitcoin initially. So Vitalik was giving his affirmation that he still holds Bitcoin till today and the rest of it. So that's the reason why I really want you guys to be bullish on Bitcoin, not just because Vitalik holds Bitcoin, because Bitcoin is the grandfather of the technology. So if you really understand the problem that Bitcoin wants to solve, then you will understand this technology much more better, because everybody continued building from that point, right? Like Vitalik, he was a Bitcoin builder before he thought, oh, Bitcoin could be better. Why not let's have a blockchain that can have applications being run on top of them, which are called decentralized application, right? And that is what gave birth to Ethereum today. So Ethereum is regarded as the world's computer. The world's computer. So we'll do a little bit of deviation now from the blockchain and understand how the computer works, and then liken it to Ethereum much better before we go deep into the technology. So just give me a second. Let me just grab a bottle of water and I'll be back. Yeah, guys, I'm back. Nice. So as I was saying before, Bitcoin is the grandfather of the technology, and then everything builds up from there. So it makes a lot of sense if you understand how the technology works before you go on to understand about other blockchains. So let's start with Ethereum, simply because we are builders. And like I told you, Ethereum is the first blockchain that brought the idea of building dApps, which is programmable apps on it, right? All other blockchains were just thinking about finance then. But then Vitalik saw that there's more to this technology. There's more to the blockchain technology than just finance. And then trust me, I mentioned this in the last class, a lot of people are still not onboarded into the blockchain ecosystem today, simply because they still look at blockchain as crypto. And then they don't know that it's not crypto. It's just crypto is just a little part of the blockchain. It's just the financial part of the blockchain. So Vitalik saw the bigger picture. He saw the bigger idea, like, hey, let's build apps on the blockchain and call them dApps. And then he went for that to build the world's computer, which today is regarded as Ethereum. Good. So let me just head over to the Ethereum book. It's going to be our best guide. I know, yeah, the Ethereum website. So we are going to be reading the Ethereum website alongside the Ethereum book as we move. So if you want to learn, if you are new into the blockchain ecosystem and you're looking for the first blockchain to get started with, we advise you start from here. Just head over to this website, read all things you are supposed to pick a wallet, get ETH. You understand why you will need all this subsequently. But we as developers, all we just want to do is build and learn. So let's learn. All right, so let's just do a high level overview of this so that you understand a few concepts and then we proceed. So first and foremost, what is Ethereum? So like I was explaining, I'll read this word for word. Cryptocurrencies such as Bitcoin enable anyone to transfer money globally. Ethereum does too, but it can also run code that enables people to create apps and organizations. Just exactly what I said, right? It's both resilient and flexible. Any computer can run on Ethereum. Learn more and find out how to get started. So this for you. Understanding what Ethereum is, let's go deeper. Oh. Sorry, guys. I think I'm in the wrong. Yeah. This is the right location. Sorry, I was in the wrong place. So this is a proper introduction to Ethereum. Let's just do a high-level overview and then we proceed. So first and foremost, it started by explaining what the blockchain is, which we have already done, but let's hear from Ethereum themselves. So a blockchain is a public database that is updated and shared across many computers in a network. Yeah. And then like most of you started explaining, a block. So a block refers to data and states being stored in consecutive groups known as blocks. This is a little bit confusing. So if you send ETH to someone else, the transaction data needs to be added to a block to be successful. So like I explained in the last class about let me open this. I think it was a worksheet. Same example about the Google spreadsheet that we did in the last class. Yeah, so let me go back at it, then we take the explanation from there. Uh-oh. Yeah. So back to this guy now. Same explanation we did, that we said we are considering this attendance sheet as a blockchain, right? Because the explanation is this. A blockchain is a distributed ledger or a distributed system where everybody has access to the data, and whatsoever transaction that happens in is being broadcasted onto the network. So the closest explanation we could get was for this attendance sheets, which we made use of a Google spreadsheet. And anybody who has a link to this spreadsheet automatically get access to whatsoever data is in this spreadsheet. And as information is being updated, automatically you are going to be getting access to it in your spreadsheet, right? That's the same thing as a blockchain. And then we explained that in a blockchain, there are what we call transactions. Now, transactions are state changes that happen to a blockchain. So anything that changes a particular state of the blockchain is regarded as a transaction. And then we said that we should consider all these different entries, that is everyone entering his name, his time in and time out, as a transaction being populated onto the blockchain. And then with this, everyone who has access to the link has access to this blockchain, or access to the list of data or the information that is contained in this system. So that's how the blockchain was built originally. So back to Ethereum now. Back to Ethereum. So each of those records of data are being gathered and saved in a block, which is what is being explained here. So every piece of information in the blockchain are saved in blocks. And then blocks are just contained of bunch of transactions. And then remember, transactions are state changes that occurs on the blockchain, right? This is just a high level overview. We'll understand properly. So how are these changed properly? How are these chained together? So chain refers to the fact that each block cryptographically references its parent. In other words, blocks get chained together. The data in a block cannot change without changing all subsequent blocks, which would require the consensus of the entire network. So this is how the blocks of data, which are a bunch of all the transactions we made, are being chained together. They say they are being chained cryptographically. And then, as I explained in the last class, cryptography is a branch of mathematics that has to do with secretly encoding data for two parties to share within one another, right? And then how does the blockchain chain information together? So every piece of these transactions that are saved in this block are being chained cryptographically. How? So let me show you a visual overview of how it works. So I think I have this website open. So let me send the link to you guys so everyone can have a look. Yeah, you can see it on the charts. Nice. Do we all have access to it? Good. So this is just a high-level overview, just to make you understand how the blockchain looks like, right? So this is it. Now, every piece of information or data, the blockchain consists of blocks. That is different transactions being tied together and then verified onto the blockchain. We understand the process of how these blocks are being verified. But before we understand how it's verified, let's understand how the blocks are being chained together. That's the idea of what we want to learn now. So every block is being numbered, starting from the genesis block to the current block that we have on the blockchain now. If you go to Etherscan or go to any of the scans of the blockchain that you have, you can know what is the current block or what is the current block that is being mined. Yeah. So this block has a number. In this case, this is just the first block. So this case is termed as block 1. But most blockchain term their first blocks as the genesis block. So if you have genesis, you know it as the first block that was being mined on the probably any blockchain. And then this block contains all the information, which are the transactions that are being recorded in this particular block. So take, for example, we did a lot of stuff. That is, someone sent money 1 Ether, someone sent 0.5, someone sent 0.2. All of these transactions are being gathered together and then saved in this block. So they are being recorded as the data of this particular block, right? So with the data, each single data of this block is being hashed. That is each single transaction. So back to this spreadsheet now. For every single transaction that you make on the blockchain, which is BD Kelvin entering his time in and his time out, the whole of this transaction is being hashed. Are we together? So down like this, and then it keeps going. So the blockchain stores data in a particular way, in a particular method. There are mostly the Ethereum blockchain stores it using Merkle trees. So Merkle trees is a method of securely storing data together in a particular block. So how does this work? So if this data is going to be stored in an Ethereum blockchain, this transaction and this transaction is going to get hashed together. This transaction is going to get hashed together. So let's call this transaction, maybe this transaction 1, this transaction 2. So let's call it 1, 2. So this is hashed together. Then this transaction is also hashed together. So let's call this 3, 4. This is stored together. Let's call this 5, 6. Like that. It keeps going 6, 7. So each of the transactions are being paired together, right? 8, 9, like that. It keeps going. Then each of these transactions that has been hashed also. So the hash of this and this is going to be stored here. The hash of this and this will get stored. Each of them is going to get paired until when they have like different hashes in here. All the hashes here are also going to be paired together. So whatever hash they get here, they will pair it together. They pair the transactions together until when they end up having just one final hash. So if 2 and 3 are paired, 4 and 5 like that, 29 and 30 are paired together, then we keep pairing them 2 by 2, 2 by 2, 2 by 2. At the end of the day, we are going to have one final hash, which is going to be here. And then that final hash is going to be hash of 1, 2, 3, 4, like that, up to 30. That's going to be the final hash that we have here. And then it's going to be regarded as the block hash or the block header. Full block that is going to get mined on the blockchain. And then with this, when these data are being collated together, it's being sent to a public mempool. So on that mempool, that's where we have like different miners on the system. So take note of this word again, miners. Now I'm just trying to give you a high-level overview of how the blockchain works. And I'm 100% sure that virtually everybody is being confused here. But trust me, just follow the train and let's go. So all this data is being stored in a particular block and then being sent to the mempool. And then on the mempool, that is where we have different miners. So miners or validators are people that maintain the blockchain. Now remember, the blockchain is a public network. It's accessible by everyone. is open for all, right? But then there needs to be people who are going to keep the sanity of the blockchain. That is, maintain the rules or whatsoever that is happening on the blockchain, because there are certain rules that are being followed. Like I explained in the last class, I talked about the consensus mechanism, right? So if this is being sent to the blockchain, to the mempool, the miners, who are the guys in control of the network, are going to access this data, this real data, this fraudulent data. Is everything being right? Does it follow the current rules of this blockchain? Is it from a right source? And the rest of it, right? And then it's going to get propagated to the network. Mahmoud Musa, I know you are confused, but just let me just drop this before you ask your question. No, Mahmoud, this is not the real attendance. I'm so sorry. This was just a dummy stuff we did in the last class. So if this whole data is being sent to the network, there are list of guys, that is the miners or the validators, people that confirm that, people that their work is just to confirm. That's just their job. So their job is to confirm that this transaction, everything is right, everything goes on well, because it's a public network, it's a public system for everyone to share. So there has to be sanity, there has to be people that will checkmate things. So as soon as this is checked and everything is valid, then transactions or the whole block is going to get propagated to the network. And then automatically, a new block is going to get formed. So if a new block is formed, people will now go on and then keep on adding transactions. So let's take for example, like today, this is attendance for yesterday. So we are going to call this attendance day 1. And then that can be treated as block 1, right? Good. Then we can head over to create a new attendance sheet for today. So let's create a new attendance sheet, and then let's say name, time in, time out. And then we put this out again. So sheet 2. And then everyone is allowed to update his name, time in and time out. That is for today's class. Because in last class we had about 50 people. Today we're having 42. So just to keep track of everyone. Right? So a new block is going to get created, just like this one that we just created now. And then users are then allowed to submit their transactions again. So everyone can now come into this list and then enter his data. Your name, time in, time out, which is recorded as a transaction. And then that's how we keep going. And then another day, we are going to create another block. So it keeps going. And then these blocks are going to be chained together. So this is what happens. Imagine we take a hash of all of these data, which is in sheet 1. We take a hash of all of this data, which is in sheet 1. So we hashed BD Kelvin together with David Sharma. We hashed Emmanuel together with Abel. We hashed Ebube together with Ruben. We hashed Abubakar together with Olorufemi, like that. And then we kept hashing them, pairing them into 2. And then it keeps going until when we had a final number or a final hash, which is this, right? And then we then proceeded to create a new block, which we are considering the new block now as a new attendance sheet. And then we put it out. Everybody started recording their data. Now, how these 2 sheets can be chained together, or how it's being chained together in the blockchain, is this. First and foremost, when we get the final hash of this one, which is this hash, we are then going to hash all the data that is going to be submitted into this attendance. We pair it and then get a final hash also. Then we hash the hash of yesterday, which is the final hash. This final hash that we got here, we are going to hash it together with the data or all the transaction hash that we hashed for today's submission. And then it's going to give us a unique hash. Now, I just realized I made a very big mistake for not explaining what hashes are before we head over to explain this concept. So let's start from a hash. So what is a hash? So a hash takes in every or a list of information or any amount of information of any length. So that means I can give this hash a data of any length and then accept back a data of fixed length. So this is what happens. I can be able to hash the number 1, but then every data I pass into this box will give me a data of fixed length. Now, every data I pass in here is going to get hash, and then this is going to be the hash. So the hash is just gibberish, just data that goes from, I think, 0 to F or so. It's just simply just hexadecimals, right? Yeah, and then this is it. I can give in data of any amount of length in here. And for every piece of information I have, I'm going to have a stipulated length of data back as output. So I give it input of data of any length, and then I get an output of a fixed length. Are we together? Perfect. So with this scenario now, every piece of information that is being saved on the blockchain or every piece of transaction while being hashed, we get is hash or an output of a fixed length, just to reduce the amount of data being stored on the blockchain. So with this, the blockchain can be able to store data of any amount at all. So this is just what a hash looks like using this example. Data of any length. I can pass in a picture in here. I can pass in a mathematical computation. I can pass in anything at all. But then it's going to give me a fixed length of data back. And then it's unique. It's unique based on the data that is being passed into the hashing function. All right, so that was just a high-level overview of how data on the blockchain are being hashed together. First and foremost, transactions are being paired and hashed until when a single hash is being generated, which is called the root hash. And then that root hash is being hashed together with the transactions of the next block of data again. So with this, if any of the data is being altered, it's going to alter the data of the next hash, which is being chained together with it. So let's also have a pictorial view of what that looks like. So this is how a hash looks like I explained. Then a block. These are how blocks look like. The number, what is it? Is it the genesis? Is it the second, the third, the fourth block? Which of the block? And then all of the data is being hashed to have this last particular hash, right? So as soon as we get this hash, this is how it's being chained together on the. Yeah, so we have the first block, which is the genesis, the second block, the third block, the fourth block, like that, and it keeps going, right? And then each of these blocks is being hashed with the root hash of the previous block so that it can be chained together. So block 1 now, which is the genesis block, has all the data that is being stored here. So all the data is being passed in here for block 1. That is all the transactions. So at the end of the day, everything is being hashed together to have this final hash, which is the root hash of this particular block. So this root hash is being hashed together with this previous hash. So every single transaction is hashed with this previous hash to get this final root hash. So this final root hash then, when a new block is created, all the data of this new block will be hashed together with the previous hash of this block 1. So can you see this hash? 000015753B is being stored here as the previous hash. So all the data in here are being stored, hashed together with this previous hash. Then we have this final root hash of the second block. So with this data is being hashed together with this one. This block is hashed together with this one. So we also get this final root hash for this block 2. Then a new block is being created also, which is block 3. So block 3 also is going to have all its data, and then all the data are going to be hashed together with the previous hash, which is the hash of block 2. So this hash of block 2 now, when it gets hashed with this data of block 3, it will give us a final root hash for block 3. Then a new block is being created like that, and then it keeps going. So with this, how are the hash being created? Remember I told you, the hash is a unique hexadecimal data that any piece of data that we give it is going to give us a unique information or a unique output. So now, every piece of transaction that was computed here for the first block is going to get attached together with the previous hash of the last block. And then it's going to give us this unique hash. So this unique hash is going to be changed together with the new block that is going to be created now. That is the data of the new block to give us another hash. So now, how do we know if a fraudulent transaction or if the blockchain has been tampered with, or if the chain has been tampered with? How do we know? Anytime any data is being manipulated, take for example, we try to change the hash of yesterday's, or we try to change the data in yesterday's transactions. So take for example, in our list of information we have here in the attendance, like I explained yesterday, BD Simon realized, or today I came to class and I told you guys, anybody that came to class exactly by 9 o'clock is going to get a gift from me, or is going to have 50,000 naira automatically from me for coming to class by 9 a.m. And then remember, all of you guys have the right to change these attendance sheets from yesterday's class. Remember, so long as you have the link, I gave you the right to be able to update it. So anybody can just go back here and then change his time. So Abdulaziz that came by 10:13 can change his time back to 9 o'clock, right? Good. So how do I know that somebody updated this data, which is the block of yesterday, and I'm trying to create a new block today? How do I know that somebody has made a fraudulent transaction, or somebody wants to change what happened yesterday so that he's going to be able to get my gift today? So back to this explanation now. If you try to update any data in here, remember, it's going to get hashed. So take, for example, somebody tries to change his time to 9 a.m. I'm going to hash it with the previous hash of yesterday to get this final root hash of today. Sorry, the final root hash of yesterday, which was block 1, right? Class 1. So if you change any data in here, automatically the hash is going to get changed, because the hash takes data of any length and then give us an output of a fixed length. So depending on the data that I pass in here, is going to depend on the output I'm going to get out here. So take for example, yesterday, the total information or the root hash was 1, 2, 3, 4, 5, 6, 7, 8. And then this was the final hash. So if anybody changes the data in here, automatically the hash is going to change. And if the hash changes, every final hash in here that is being sent to block 2, which is being hashed with the data of block 2, is going to change. And then with that, the blockchain is being altered. And then we are going to have this final red this red sign to show us that something was altered, or the data of yesterday was being altered, right? This is a little bit confusing, but let me hear your question to know your level of confusion. So, Tech Explorer, let's get you.
Sir, but I'm trying to understand. Like this hashes, does it mean that it's combined different information to make it one, or like to make it one? As I'm seeing, as I'm like the way I'm understanding it, like it will combine the one
Yeah.
day one, day two to make it one, day three. So maybe if you want to deliver the information instead of delivering it differently, it will be in one address or that kind of thing.
Can you come again with that, with the last part, please?
Okay, like it's combined all the hashes to form one database whereby it's only one information will be seen in the end users. But when you go to the main user, it have different hashes. But when it's being hashed, it form only one database, that kind of thing.
Yeah, at the end of the day, we are just working to have one final root hash. So everybody's transaction, anybody's data that is being sent to the blockchain, for it to be mined to a particular block, we just need one particular root hash at the end of the day. So every piece of transaction is going to get hashed to get appeared until we have one particular one to just give us a proof that so that anytime that any of the transactions is being altered, we are going to know that something happened in there. So that's just the concept at the end of the day. Yeah, so we'll go in depth to understand better how each of these pieces work before we try to join them together. Yeah, so let's get you.
Well, sir,
Jethro.
all of them are achieving the same outcome. Or if they come to form one hash address, all of them achieving the same outcome. Or like in the back end, are they different outcome, or are they achieving the same outcome in that one address?
In this method now, I'm just trying to show you the mechanisms of how the blockchain stores data. You understand?
Okay.
Because remember, we have a centralized database. Are you a back-end dev or a front-end dev? Front-end, okay. This is it. In your back-end that you're working with, right? There's a centralized database, which is where all our data is being stored. And then that database is being controlled by one central entity, right? Or one central authority, right? And then which we explained in the last class, there is a problem at the end of the day. All data needs to be stored in one central location. That's the idea of the blockchain, so that it doesn't get altered and the rest of it, right? So for us to gather imagine gathering everybody's database. That is, we are saying Facebook, Twitter, Instagram, WhatsApp, Access Bank. Everybody should bring his data and store it in one single place. You get the point? So for that to be possible, the blockchain uses a different pattern to store this data, because all data is being stored in one place. And then we don't want those data to be tampered with while they are being stored, because that's the idea of keeping it in one place. We understand that if it is in different location, it can get tampered with. But storing it in one place, we have one central place where we can get all our information, which can be different servers, right? So how do we manage this data, or how do we store this data, is the concept that I'm trying to explain currently, using the blocks, how they are being chained together to be able to have the blockchain at the end of the day.
Okay, I don't understand.
All right, cool. Jethro.
Okay. My concern is about the blocks. So you gave an example with the spreadsheet of the previous attendance we had in the last class, and then for each two transaction, they will be matched together, and at the end of that transaction, we'll have like a hash that connects all the transaction from those transactions that were paid. And then today you created a Google Sheet again, wanting to chain that attendance we did that other day with this one today. When I was reading some documentations, I get to find out like those data have maybe a limited size. That is a block that can contain, is it a particular size of data before another data can be formed? Or can we just form another block just like that? Or is there a limit to the amount of data a block can contain before you get to form another block? Because in that documentation, I saw something like 4 MB. A block contains a size of 4 MB before. So I just want clarity on that, if it is possible. Thank you.
Yes. That's a very good question and a good observation. Yeah. So we'll go deep to understand how blocks work, how they are being generated, and the rest of them. Right. So a block has what is called the block limit. There's particular size of data that is supposed to be stored in a particular block. So there are different things that determines the creation of a new block. But then a block is being created every 12 seconds. That's in the Ethereum blockchain. Some blockchain, it differs depending on what blockchain you are working with, right? But for the Ethereum blockchain, a block is created like every 12 seconds. So which is basically called a slot or so. So every 12 seconds, a block is being created. And then the data that is being fitted in that block must contain the size of the data that, or the max size that a block is supposed to contain. And also there's what's called a gas limit. But we don't have to understand about that for now, about the gas limits. But then what you said is correct. But then we'll understand how it works. So there's sizes. Each block has a particular size. That's true. Yeah, Akanimo, let's get you.
Okay, so my question is regards to still this Jetro question, just like how you just mentioned now that a block is created every 12 seconds. So I read a book also that talks about conjunction. So let's say people make a lot of transactions in a second. Does it really mean, even if, let's say for instance, normally, let's say 100 transactions will form a block, but then before a 12 second, we have like a million transactions, just for example, will it still package the 12 transaction or spread it to different blocks?
So depending on the blockchain, but basically for now, what the blockchain is able to handle is handling it per 12 seconds. So it just gets it and propagates it as fast as possible. So once it reaches block limit, automatically it's going to propagate it to the network. So for the Ethereum blockchain, it's basically 12 seconds for now. But we haven't gotten to that extent where the blockchain has over 1 million transactions per second or 12 seconds. I don't think any blockchain has recorded that. So we can't seem to explain this scenario, I as a user. So your questions are going kind of deep. So I want us to understand all of these moving blocks gradually before we go deep into it. So, well, is there any more hands-on? I know there are confusions.
Yes. Yes.
Yeah, okay, shoot.
Okay, Mr. Manoah. Yeah, thank you very much. So when you were talking about hashing and how miners were able to verify transaction on each block or something like that. So it makes me remember there was a time I downloaded a software and then they specify in order to know like a checksum something related to hashing also. So when you run that particular check on that particular software, you can be able to know if it has been altered or not. So that's so I was just so that was the thought that came to my head also, Sha. And also the same way we do like work the password sometimes. You might not know the password of the person, but when it's hash, you store the hash of the password sometimes on the database, and you don't know the particular password and you don't know the key that was used in hashing it. So when you enter your password, the system is able to detect if it's correct by checking the hash to the hash that is in the database, something like that. So
Nice.
that is just okay.
Are you a backend dev?
A little bit of, but I'm a front end person, but I have a little
Or
bit of idea back end.
experience on backend, so you understand how hashes work and then a little
Yeah,
bit of
yes.
it's just
A little bit.
in how security, because you know bunch of people's data are being stored there, so there needs to be
Yes.
security and then the rest of them. That's where those hashes come in. But then let's go to the
Okay.
Ethereum book. I think that's the best location where we have to be at.
Okay.
So let's take it from the Ethereum book and then let's go. So no more hands. So this is the Ethereum book. Let me send the link for you on this call. You can also follow me up if you want. And then since you want to learn about Ethereum, this will be our best go-to location. So you have to follow this book alongside the website, alongside other resources. Because as you can see, this book was last updated 4 years ago. So that simply means some informations in here are not valid. But the most information we need to know as beginners for now are very much valid in here. Just to understand the concept of how the blockchain works. Ethereum, to be specific. So Ethereum is often described as the world's computer. But what does that mean? Let's start with a computer science focused description and then try to decipher with more practical analysis of Ethereum's capabilities and characteristics while comparing it to Bitcoin and other decentralized information exchange platforms. So that's just what this book will be doing. We'll be understanding Ethereum alongside Bitcoin because Ethereum came as a result of Bitcoin. It saw some inefficiencies in Bitcoin and then it built upon it. Because Bitcoin, like I told you, doesn't support programmable apps until now. I think now they've started, right? But previously it wasn't. So that was what Ethereum saw, and then Ethereum built upon it. So for computer science perspective, Ethereum is a deterministic but practically unbounded state machine. So consisting of a global accessible singleton state and a virtual machine that applies changes to that state. So that's just how the blockchain works. It's just a state machine. So when they tell you what's a state, React developers are going to understand this much better. React devs, if you understand just like the normal state in your React, right? Good. Use states and the rest of it. So you have a particular data, maybe you have counts, and then you have a function that updates the state of count. And then you can also read count directly from your states, right? That's the same thing with the blockchain. So since it is one single information that is being stored, or everybody's data being stored in one single place, so the state of every data or every block or every transaction is being regarded as the current state of the blockchain. So let's take, for example, now, if we have added in our list or in our attendance list, if there is have just 30 names in this list, it means the current state of the blockchain has only 30 people registered. But as soon as somebody comes in here and submits a new transaction, submits a new name to show that he attended class today, maybe let's say I entered my name, Manoah Luca K. Automatically, the state will automatically get updated. So if you go to your Google Sheet, you will see that before this name was not there. But now, maybe before we had just 31 names, but now we had just 30 names, but now we have 31 names on the list. So that's the same thing with the blockchain, and that's how it works. It's just one state machine. And then every single transaction that is being made, the state is being updated because everybody's data is stored in one place. So once one more data is being updated, the state gets changed automatically. So that's just what this paragraph is trying to explain. So for a more practical perspective, Ethereum is an open source, globally decentralized computing infrastructure that executes programs called smart contracts. Perfect. So this a better introduction. So Ethereum is open source and is a computing infrastructure. So just exactly as how your computer works is the same way as Ethereum works. They say, what is a computer? So let's have a proper explanation of what a computer is. Someone should define it for me on the call.
I think it is an electronic device that accepts data, stores, and process and give us information.
Perfect. So that same thing that your computer does is the same thing that Ethereum does. So Ethereum is not just a cryptocurrency. As a matter of fact, it's not. It's Ether that is the cryptocurrency. So Ethereum is the world's computer, the same thing as your computer. But this time around, remember, in your computer now, everybody has his own individual computer. So it depends on the data that you give to your computer. That depends on what your computer is going to process, and that depends on the information that your computer is going to give back. But then Ethereum is one computer for everybody to make use of. How? So all of us are allowed to give our information to one single computer, and then that computer can be able to process it, and then that computer can be able to give us information back at the end of the day. That is what Ethereum is in short form. Are we clear? Good. So let's go. It says it consists of a singleton state, which is that one single state that we have, and then a virtual machine that applies changes to that state. So there's a virtual machine. Now your computer normally has a processor that processes whatsoever happens behind the scene to be able to give you information or to update the state of your computer. Like take for example, if you go to your computer and then you press on the shutdown button, what happens is your computer processes it and knows that, hey, this guy wants to shut down. And then it goes and shut down the computer completely. But then in it, what happens is there's a virtual machine that determines whatsoever you want to do. So if you want to make a transaction or you want to make a state change, as soon as you make it, it's going to process it for you underneath with the virtual machine to know whatsoever it is you want to do, and then it applies those changes to the state of the blockchain, which is one single computer that we all make use of. So for a more practical perspective, Ethereum is open source, globally decentralized computing infrastructure that executes programs called smart contracts. So on our back end, we run our normal back end codes that has an API at the end of the day that just fetch data and gives us. But on the blockchain works with what we call smart contracts. So smart contracts are what determines what happens on the blockchain. So what are smart contracts? So smart contracts are piece of logic, piece of codes, programmable codes that we all know, but then they are being executed on the blockchain. That is what smart contracts are. So at the course of this cohort, or at the course of this bootcamp, we are all going to be learning about what smart contracts are and how to write smart contracts. So smart contracts are just piece of logic, the same code that you write. But this time around, not just JavaScript. You start writing different codes like Solidity, Cairo, and the rest of them for you to be able to write smart contracts. So smart contracts are codes that runs on the blockchain. And then these codes determine whatsoever happens in the Ethereum virtual machine. And then the Ethereum virtual machine is in charge of applying changes to the states of the global accessible singleton states that we all have, which is known as the blockchain. All right, so that's Ethereum for you. So Ethereum platform enables developers to build powerful decentralized applications with built-in economic functions while providing high availability, auditability, transparency, and neutrality. That's just what Ethereum helps us with at the end of the day, right? So compared to Bitcoin, what is Ethereum? So like I told you, Ethereum is the, Bitcoin is the grandfather of all blockchains. So many people will come to Ethereum with prior experience of cryptocurrencies. Yeah, for sure. So most of you were not builders before, but I'm sure you know what Bitcoin is. I'm sure everybody here knows what Ethereum is. Some of you even have it in your wallet, but you have not built on it before. So Ethereum shares many common elements with other open blockchains. So a peer-to-peer network connecting participants. So these are some of the components of a blockchain. They are just giving us a highlight in here. So every blockchain must have a peer-to-peer network connecting the participants together, a Byzantine fault tolerance consensus algorithm for synchronization of states. So the same algorithm that we talked about, proof of work, proof of stake, we are going to be explaining that. Every open blockchain needs to have that, which is the same as Ethereum. And then the use of cryptographic primitives, such as digital signatures and hashes. I've explained some hashes here, and a digital currency, which is Ether. So every single blockchain is supposed to have it. And then the same, Ethereum also have this, just like Bitcoin. And then yet, in many ways, both the purpose and construction of Ethereum are starkly different from those of other open blockchain that preceded it, including Bitcoin. So Ethereum's purpose is not primarily to be a digital cryptocurrency or payments network. While the digital cryptocurrency Ether is both integral to and necessary for the operation of Ethereum, Ether is intended as a utility cryptocurrency to pay for use of Ethereum platform as the world's computer. Right, so I will explain this concept now. So before we go deep into Ethereum, since Ethereum is the world's computer for everybody to work with, we first need to understand how our normal computer works. That's what we need to know. How does the normal computer works that we use? So your computer is a Turing complete machine. That is, a computer is a machine that every single computation or anything you give it at all to process, it can be able to process it. So long as you give it the relevant resources and then you give it the relevant time for it to be able to process that particular information, the computer is going to process that for you. And then that's the same thing with the blockchain. Or that's the same thing with Ethereum. So Ethereum also processes every single piece of transaction that we gave it at the end of the day to give us information back. But then the problem is this. Ethereum, sorry, your normal computer sources, and then they are aggregate amount of time, simply because it's a Turing complete machine. And then a Turing complete machine is a machine that performs any computation at all. That's what a Turing machine is. And then that's the same concept that your computer adopted. So let me just search what a Turing machine is so that we have proper explanation. So we are going to be jumping from different concepts. Just know that the blockchain has to do with different concepts. And that's why I was preaching that your job is just to read. So if you don't read, you are not going to get most of this concept. It's going to be very confusing for you. So you have to go deep down to read by yourself before you understand how this whole technology works. So first, let's understand what a Turing machine is. So a Turing machine is a mathematical model of computation describing an abstract machine that manipulates symbols such as strip of tape according to a table of rules, despite the model's simplicity. Okay, no. First, before we know what a Turing machine is, let's know what it means to be Turing complete. Yeah. So our computers are Turing complete, which means it can perform any piece of transaction at all. So any data you give the your computer can be able to process it for you, because that's its work. It says accept data, process data, stores data, and then give out information, right? Good. And then we liken it to the blockchain. So what does it mean to be Turing complete? Okay, so it's said to be Turing complete. So a programming language or a cellular automation is said to be Turing complete or computationally universal if it can be used to simulate any Turing machine, which we have read, and they have lost us again. So this means that this system is able to recognize or decode other data. No, this is confusing. Turing completeness is used as a way to express the power of such data manipulation or manipulation sets. This doesn't explain it better. But then for a machine to be Turing complete, it simply means that it can perform any piece of transaction or any piece of computation being given to it to perform. That's where you know that something is regarded as Turing complete. And then that's the same thing with our computer. Anything you give our computer can be able to manipulate. Anything you give our computer can be able to process it. And then at the end of the day, give us information, which I said that that's the same thing with the blockchain or Ethereum. Ethereum is the world's computer. So any piece of computation you give Ethereum, Ethereum can be able to perform for us at the end of the day. And then the definition of Turing completeness says it performs the same thing as a Turing machine. And then as I was reading a Turing machine, it says it's a mathematical model of computation. So the Turing machine was invented by Alan Turing in 1936. And then this was the idea behind him creating this machine. So it was a Turing doctoral advisor who later coined the term Turing machine in a review. With the model, Turing was able to answer two questions in the negative. So does a machine exist that can determine whether any arbitrary machine on this tape is secular? So does the machine exist that can determine whether, oh, no. This is the wrong resource. Wikipedia is actually the wrong resource for us to go to for now. So let's just go back here with our simple explanation of what a Turing machine is. Just know it's a machine that can be able to perform any piece of transaction. And then the Ethereum or the world's computer is the same as that. But then the problem is, what if someone gives the Ethereum a transaction that is infinite, or a computation that takes like a whole lot of time or takes the whole day? Remember, it is a computer that all of us have to share. So the first person's computation has to go through first before the second person's computation will go through, right? So to be able to coin that or to make everything better accessible for everyone, Ethereum introduced a utility currency. So the utility currency is used to pay for using the world's computer. So unlike our normal computer that we are making use of, that we have access to it, we don't pay any single money. On Ethereum, for you to use Ethereum to make computation or to process data, you have to pay, which is what is used as the utility currency as Ether that everyone uses today. So Ether is the currency that is being used to pay for using the world's computer. Let's use it there. Let's leave the definition at that. So unlike Bitcoin, which has a very limited scripting language, Ethereum is designed to be a general purpose programmable blockchain that runs a virtual machine capable of executing code of arbitrary and unbounded complexity. So these are the components of a blockchain. So components of an open blockchain. Now, first and foremost, I need you guys to know that there are two different types of blockchain, public and private. So not all blockchain is being opened for everyone. Some people build private blockchain, which in the course of this bootcamp is not what we are going to be studying about. But then mostly what we are going to be studying about is public blockchain, which is what we are interested in, what everyone makes use of. So these are the components of a blockchain. So a blockchain must consist of a peer-to-peer network, consisting of participants and propagating transactions and block of verified transactions based on the standardized gossip protocol. So the blockchain works with a gossip protocol, which means as soon as a transaction is being received, it is being propagated everywhere so that everybody is going to have access to it. And all the nodes can be able to see the transactions. So that if one node falls, the other node has the right to be able to display that transaction for other people to see. Right? That's just the concept of this gossip protocol. And that's why we said the blockchain is transparent, open to everyone. Anything you do in the blockchain is visible for everyone to see. And then the only way this is being visible is with the work of a gossip protocol. Next is the messages. So a message is in form of a transaction, which is representing state transition. So since this is a single state, like I explained for React devs that all of us make use of, for every single change that everybody makes every single change that everybody makes in the transaction is being submitted in form of messages. So messages popularly are known as transactions. And then transactions are regarded as the records I told you guys for every single data or for every single attendant that is being marked by everybody in this class. And then for every single piece of this transaction, a state change is being made. So there's a state transaction. So take, for example, before we didn't have Akanimo's name in the list. If Akanimo goes on the list now and add his name, automatically the state of the blockchain changes. So everybody will see that, oh, before we had just 30 names, now we have 31. And then the new person on the list now is Akanimo. And everybody on this class or in this class that has access to the link is going to automatically have access to seeing the new state change. So that's just the second component of the blockchain. And then next, a set of consensus rules governing what constitutes a transaction and what makes for a valid state transactions. Good. So that's just the work of the consensus rules. It checks what is supposed to be constituted inside of a transaction. Because remember, each of these transactions is being hashed together to have a particular piece of block at the end of the day. And then this piece of block is what is being updated to the blockchain and being changed together for us to have one single blockchain, which gives us one single state. So each of these transactions follows a consensus rules. So we are going to be understanding what these rules are that each of these transactions follow for us to know what a valid transaction looks like. That processes transaction according to the consensus rules. Good. So like I told you, your computer has the work of doing all the processing. So your own job as a developer now is to give your computer the piece of information, or as a user, take this information or take this data, and then your computer is going to process it and give you back information. That's the same thing with the blockchain. The blockchain is just a state machine. And then for every single piece of transaction we give this blockchain is going to process this transaction according to the rules that is being set, which are the consensus rules. And then if the transaction follows that particular rules, automatically it's going to get propagated to the blockchain. Perfect. So a chain, the next, another component of a blockchain is a chain of cryptographically secured blocks that act as a journal of all the verified and accepted state transition. I like this explanation very well. So every blockchain must have a chain of blocks, which is what we explained here. Where is it? Here. Good. So every single piece of this block, that is block 1, must be chained with block 2. Block 2 must be chained with block 3. Block 3 must be chained with block 4. How are they chained together? I told you guys that every piece of information being stored inside of this block, the block is made of transactions. And every single piece of transaction that is being stored in this block is being hashed together to have this final hash that we have here. Then this final hash is being hashed together with every single piece of data in here for block 2, together with the previous hash, which is the hash of block 1. It is being hashed together to give us one single hash again. Then a new block is being created, which is block 3, and then it keeps going on to the last. So with this, anytime we temper anything in block 1, if we temper anything in block 1, remember the hash is going to be changed, simply because it means that the data in block 1 has been changed. So if the data is being changed, remember we are hashing the final hash of block 1 together with the transactions in block 2. So if the final hash here change, it means that the hashes in block 2 are going to change, and then automatically the final hash for block 2 is going to change automatically. And then with this, we know that the blockchain is being tempered, and then there was a fraudulent transaction. So this is how the blockchain maintains its security, is by using hashes to be able to chain these blocks one after another. This is just the explanation. So every blockchain must compute of this chain of cryptographically secured blocks, which are just a journal, right? And then it keeps going. And then a consensus algorithm that decentralizes over the blockchain by forcing participants to cooperate in the enforcement of the consensus rules. So now, we are all humans, and then everybody has his own rights to one particular system. Do you know how people are going to mismanage it? Have you people had access to a public toilet before? Do you see regularly how people misuse it? So that's how it wants to be tamed now with the blockchain. So simply because it's the world's computer, we want to maintain how it is being used. Because we said it's the world computer, somebody can go and steal the mouse and go and be using the mouse in his own house alone. Because it's the world's computer. Somebody might choose to go and steal the monitor and go and be using, because it's accessible by everyone. But there are supposed to be rules so that people are not going to steal the mouse, or people are not going to steal the keyboard, or people are not going to leave the computer on after they made use of it. Are we clear? So that is the consensus algorithm we are talking about here. It controls how everybody uses the blockchain. It forces the participants, people who are using the network. These are the rules that you are supposed to follow so that we do not misuse this particular world's computer that everybody is supposed to have access to. Perfect. So one more, it has an open source implementation, which is called a client. So this is going to be a little bit more technical, but then these consensus rules are being run by clients. So clients at the end of the day are just, so at the end of the day, we have nodes. Nodes are just someone else's computer, which they follows all the rules, all the consensus rules of the blockchain. It must be a high-end computer. That is, it must have high computational power, maybe of high gig. In the course of this class, we will understand the type of computer that you need to be able to run a node. And then as a node, you are going to be the one who follows the rules to be able to make these state changes. So the node receives the blocks, and then they propagate the blocks to the blockchain. And then before every block is going to be propagated to the blockchain, the block needs to follow the rules of the blockchain. which is those consensus rules. If it follows those rules, then it's going to get propagated. But then the nodes now run a particular client, simply because these nodes are a computer, your normal computer that you know. But then they must have high computational power, I think very high storage space, and the rest of them, right? High RAM, etc. You can't just use your normal computer for it. It has to be very high because it's going to be processing multiple transactions, right? To be able to propagate it to the network. So every single node runs this client because it's a normal computer. And then remember, your computer runs an operating system, right? Like now, everybody has his own operating system for his computer. Some people have Ubuntu, some people have Windows, some people have Mac, and the rest of them. So those are the different clients or the operating system that we run in our device. So same thing as those nodes that we have, those Ethereum nodes. These nodes, at the end of the day, they run a particular software, and then this software are regarded as clients, which is what governs the rules of how the blockchain or how transactions are going to be propagated to the network. So most of these components are usually combined in a single software client. For example, in Bitcoin, the reference implementation is developed by Bitcoin Core open source project and implemented as the Bitcoin client. In Ethereum, rather than a reference implementation, there is a reference specification, a mathematical description in the Ethereum yellow paper. So you can go on and understand that properly. It's getting more technical, and I don't want to go that way. So let's talk about the birth of Ethereum. So all great innovations solve real problems. Ethereum is no exception. Ethereum was conceived at a time when people recognized a power of the Bitcoin model. We were trying to move beyond cryptocurrency application, but developers face a conundrum. So that was exactly what happened. The world was moving well. Everybody was working on Bitcoin and everything was moving fine. Decentralized finance, I can send Bitcoin. No bank is controlling my money. It's awesome. It's good to go. But then until when developers were trying to build applications on top of this amazing technology, that was where they realized the problem. And then Ethereum was being given birth to. And then Vitalik thought about it. Why not let's build programmable applications on the blockchain? So in 2013, Vitalik started sharing a white paper. You can go deep to read this. This has no need with the class, so that you understand properly how this works. And then these are the different 4 stages of its development of Ethereum, right? This is just a high-level overview for us to know what it is. And then we've talked about Ethereum components. So let's just jump over to the introduction because we don't have much of the time. So you guys are supposed to be the ones that will be doing the reading. Good. So there's where we are heading to. So before the end of this class today, we are supposed to understand more about Ethereum, understand about blocks. Blocks work now. We said they contain a bunch of transactions that at the end of the day are being hashed together and propagated to the blockchain. So let's talk about intro to Ethereum, Ether, and the rest of them. So Ethereum basics. In this chapter, we will start exploring Ethereum, learning how to use wallets and how to create transactions and how to run a basic smart contract. So Ether, which is the currency unit of Ethereum, remember, like I explained to you in the last class, Ethereum is being powered, in this class, Ethereum is not the is not just cryptocurrency. It is the world's computer. But then the world's computer, every computer does process information, and then give us data at the end of the day, right? And then Ethereum is the world's computer. So we want to tame how people make use of it, so that somebody will not just go and run an infinite loop, or maybe run a computation that might take a whole year, and he have access to the computer, him alone. So that's why they gave birth to Ether. And then Ether is the currency. So when you hear people say, I have one ETH, I have two ETH, at the end of the day, they are referring to Ether. Don't go and say, I have one Ethereum or I have two Ethereum. You are wrong. Ethereum is the blockchain. Ether is the currency. So Ethereum's currency unit is called Ether, which is identified also as ETH. Remember, I introduced the components of the blockchain, and then I said every blockchain is supposed to have a native currency, just like Bitcoin. Bitcoin has BTC, right? At the end of the day. Same thing with Ethereum. Ethereum has Ether. So this is it. Ethereum's currency unit is called Ether. It is identified as ETH, or this symbol for Greek, or the letter XI that looks like a stylized Ethereum E, or this. So any of these can be used to highlight Ether or know that this is Ether. But popularly, this is what we make use of, you know, or ETH. If you see it, you know, or Ether, any one of them. So Ether is subdivided into smaller units because it's a currency, right? So it's been broken down into smaller units, down to the smallest unit possible, which we are going to be having a look at today. So every single piece of Ether has, this is it, the max. It has about 18 decimals, which is about 18 zeros, just like our Nigerian currency. So we have the smallest unit, which is Wei. So one of these is Wei, which is regarded as maybe 0.000 to 18 zeros of 1 Ether. This is the Wei, which is the smallest unit. In Nigeria, we call this Kobo, right? To Naira. In dollar, it's being called cents, and the rest of it. So that's the same thing with the Ether. And then we have all of these. These are their names. Femita, Picoeta, which is popularly known as Wei. From Wei, we have Kilo Wei, which is just 10 raised to the power of 3, 1,000 units of this. 10 raised to the power of 6, which is Mega Wei. We have Giga Wei, which is Gui. We are going to be talking about this more often. Mostly we'll be talking about Wei, Gui, and Ether. We have Micro Ether, which is about 12 zeros. We have Fini and the rest of them down to Ether. So you don't have to worry about Kilo Ether and Mega Ether for now. This is just what the currency looks like. Yeah, Nancy, let's hear from you. Let me pee. Sorry.
Just want to let you guys know that they've dropped attendance list. Did you hear me? I'm talking about the attendance list. It has been dropped in the comment section.
Okay, yeah, thank you, Nancy. Hope you're all aware. All right, guys, so you can have a look at all the different denominations of the blockchain, right? And then Most blockchain also, if you guys get onboarded into the blockchain ecosystem, the first thing they will start telling you is get a blockchain wallet or the rest of them. So let's talk about wallet a little. So the term wallet have come to mean many things, although they are all related on one-day to one-day basis, boil down to pretty much the same thing. We use the term wallet to mean a software application that helps you manage your Ethereum account. So in short, an Ethereum wallet is your gateway to the Ethereum system. It holds your keys and you can create and broadcast transactions on your behalf. Choosing an Ethereum wallet can be difficult because, sorry, we don't have to go down here. So this is the important thing. Mostly what people will tell you is the first thing is your access to the blockchain is using a wallet. Yeah, simply because the blockchain is a blank box that contains your pieces of information. But before you can have access to the blockchain, you need a blockchain wallet first. Now, why do you need a wallet? A wallet helps you manage all your keys. Now, in the blockchain, you are going to understand how to have access to it, which is supposed to be like in the 4th chapter of this. Can you see? 4th, talk about keys and wallets and the rest. But this is just more of having a high-level overview, why you need a wallet. Because some people will say, why can't we just relate to the blockchain? Why can't we have access to it? Why do we need a wallet at first? So a wallet helps you manage your keys, simply because in the blockchain, you need 2 keys, most importantly, which is the public and the private keys. So the public keys is to help you. The public keys serve as your identity on the blockchain, while your private keys serve as your signature that gives right to make transactions on the blockchain. So this is a simple example. Take note of it as this. Take note of look at your Ethereum wallet as your normal PalmPay account. So your PalmPay account, you have two addresses, right? First and foremost, you have your OPay. OPay is more popular. So first and foremost, you have your OPay account, which is most importantly or popularly known as your phone number, right? So your phone number is your identity on OPay. So with your phone number, I can be able to send you money. With your phone number, I can be able to know your name and the rest of them. Because I heard some people are using OPay and PalmPay as Truecaller now. And then lastly, look at your private key as your PIN that you can use to sign or you can use to transfer money from one person to another. That's how you look at your private key. So your Ethereum wallet helps you to manage all of these keys. So you know your normal wallet, your normal PalmPay, it helps you to manage your money, right? But in Ethereum or in the blockchain, your money is naturally being saved on the blockchain. But then a wallet helps you to manage your keys, which gives you access to the blockchain. So before we get started, before we go further, and fully get embedded into the ecosystem, I would say this is the best time for us to have an Ethereum wallet. So everyone should just head over to have an Ethereum wallet right now. And then let's just have it be lost, right? So you can get your wallet from MetaMask. So MetaMask is a browser extension. There are different wallets, MetaMask, Jax, MyEther wallet, and the rest, and plenty more wallets that you will know about. But then for a start, I would say the best wallet to get started with is the MetaMask. That's what most of us got started with. And then MetaMask can be run as a normal browser extension. Yeah, Phantom too. So a lot of you guys know Phantom because I'm sure there are Solana guys in the group. So you can choose to have any of those. But because we are talking about Ethereum, get your MetaMask. So let's try to install a MetaMask wallet. So all I just have to do is head over to MetaMask extension. So depending on what laptop you are using, just go to the extension and then check out MetaMask. And then all you have to do is click on, so I have it added already. This is it here. If you have it added, you are going to see it as one of your extensions. So I have it added, that's why it says remove. But if it wasn't added, you see add to Chrome or add to Brave. So I'm going to give you guys 2 minutes for those of you who do not have it to just head over to have a wallet now, and then we'll just try to do a normal regular setup. So guys, I'll be waiting in the next 2 minutes. So as soon as you are done, just let us know in the call or give us a thumbs up so that this will be your first onboarding to the blockchain. We have just 1 hour to finish the class, and then we haven't discussed about a lot of things. So let's do this as fast as possible. So let me start seeing your emojis if you have already added the wallet. Nice. I'm sure you have watched Patrick Collins' course, so he has made a lot of it.
Are you going to create an account or we are just going to edit it?
Yeah, you don't have an account, so create one. Now, before you get that, just get the extension. That's just what I want now.
Okay, I already got the extension. Thank you.
Anybody who has added the extension, just raise up your hand so I know where to get that. So just 5 people. But most of you joining from your phones. Okay. So I think I will need someone to share their screen so that I'll be able to explain this. Because I already have MetaMask installed, so and I don't want to remove it. There are assets in there. Abbas, since you're already there, just share your screen.
Okay, I'm using laptop, sir.
Yeah, I thought you added to your extension.
Yeah, I already add the extension with through my computer, but I'm using my phone for the meeting up.
Oh, okay. Who else is available that is joining with his computer? So that let's just try to set up a wallet. All right, Farida. Nice. So let's try to create a new wallet together with Farida. If you are there, you can choose to proceed. So we can either choose to create a new wallet or import an existing wallet. So we can import an existing wallet in different ways. So take, for example, we have created a wallet before. There are certain data is going to give us, like seed phrase, private key. So with that, we can be able to use it to import an existing wallet. But for now, that's not what we want to do because this is our first time signing up. So we want to create a new wallet. So Farida, you can create wallet.
Should I click on I agree?
Yeah, I agree. We don't have a choice. We have to agree.
Okay.
So now you select a password.
Okay.
Make sure it's strong. Okay. So next, asking you to secure your wallet. I think I can play this video. Let's just watch it. Yeah, so if you want to secure your account, this is the best way. Now what will happen is they give you different keys, which is your recovery phrase. And then, so this is your recovery phrase. Your recovery phrase is the master key. Then it's regarded as your recovery phrase. With that, if you provide that phrase, your wallet can be recovered. So I will advise any of the keys that is being given to you, do not let anybody have access to. The only keys you're allowed to share with others is your account address, right? So there'll be no need for this. Just stop this now. So this is just telling you the better way for you to secure the current keys that is going to be given out to you.
Should I continue?
Click on God. Yeah.
Sir, should we skip the place to secure our wallet, sir?
No, if it has given you, has it given you a phrase?
No, sir.
Go to next, please.
Okay.
Farida. Done.
Should I click learn more or should I skip?
Just keep this.
Okay.
I think you skipped where he gave us our phrase.
Yes.
Okay, yeah, when you are supposed to secure. Yeah, so I really wanted us to have a look at that. So I don't know whether you can delete this and start over again. Just delete the extension and start again.
Okay. Extensions.
Are you still sharing your screen?
No, I stopped sharing so that I will install it. Then I will open it
Okay.
again. Installing that. Okay. I'll share the screen again. Can you see the screen?
Yeah.
Okay.
Yeah, so agree. Let's go again.
Sorry, I want to ask for someone that already has an account, what should I do?
No, yeah. If you already have an account, no need. You are already good to go, except you import it or you continue. So secure my wallet, recommended. Yeah, so secure now. Good. So calm down. It gives you a seed phrase now, which is like 12, about 12 of them. You have to arrange them properly. And then this can be used to recover your wallet anytime you lose it. So to reveal it, you have to click. So click review. Good. And then the best advice is you write this down, like on a paper or somewhere, and hide it so that you can be able to recover your account or your wallet whenever it's missing. Because trust me, I've ever lost an account like this and I had money in it, and that's how it went. So, and then it's not recommended for you to show anybody this, because automatically with this particular data you have given out now, all these 12 digits, I can be able to recover your wallet in my device and even make transactions with it.
Okay.
Are we clear? So immediately after this call, I will advise you delete this wallet and
Yeah,
then
I understand.
yes, sign up another new one again. So, but then these are the seed phrase, and then you can be able to recover your wallet with this. Make sure you store this because there's no customer care. Remember, if this is gone, it is gone. So click on next and let's proceed. So, now they will ask us for it. Yeah. Me too, I forgot. Can you click the second step?
Let me
click
just
now.
copy it somewhere.
Yeah, just take a picture on your phone.
Okay. Let me do that.
Yeah, so you enter that same exact words. And then you confirm.
Okay.
Just click got it. Next, done. And then you are good to go. So a wallet finally that manages her keys to be able to have access to the blockchain. That's just what we did now. So as we go further, while everybody will be understanding how to use a wallet, understanding how it works properly, because the work of this is not just to store your keys, though that's the primary job. So I'm seeing some hands up. Can I take the questions? Then we proceed as fast as possible. Because I'm supposed to introduce a lot of concepts today, and then it wasn't possible. So Jethro.
Should I stop sharing?
Yeah. Yeah. Those of you that are raising up your hands. Come on. Okay, let me proceed. So now we've created a wallet, and so the next thing we're supposed to do after creating a wallet is to have Ether in it, have some funds, so that you people will enjoy the idea of share, or you people will have the feel of interacting with the blockchain via making monetary transaction, but this time around with test tokens, not using the main Ether, but test Ether that exists, right? So you can read through from where I stop next, and then you can be able to try to do that. I will also drop relevant locations to where you can get test Ether. But for now, you have not known the reason why. So that's why I'm not stressing on doing that. All right. So you've now created a wallet and sent receive Ether so far. You've treated Ethereum as a cryptocurrency. So, but Ethereum is much more. In fact, the cryptocurrency function is a subservient to Ethereum's function as a decentralized world computer. Ether is meant to be used to pay for running smart contracts, like I told you guys, right? Which are computer programs that run on an emulated computer called the Ethereum machine or the Ethereum virtual machine. So the EVM is a global singleton. I don't have to read this. Okay, I have to. The EVM is a global singleton, meaning that it operates as if it were a global single instance computer running. EVM works as a single computer. So anywhere you run it, it can work. And then you don't need lights. All the EVM needs is internet connection. So long as there's internet, the computer exists. So long as the internet exists, the blockchain exists. So each node on the Ethereum network runs a local copy of the EVM to validate contract execution. So each node, like we explained the first time, we said nodes are the guys that run the network. So they oversee. For the fact that it is public to everyone, there must be people who are in charge of it. Like Nigeria as a country is a public country, open to every single Nigerian. But in the end of the day, we have the executive to take charge of whatever is happening in the country, the legislative, the what's it called? The lawmakers, or what are their names? legislative, that's their name, proper. So that's how it is. Now, same thing with Ethereum, right? It is the world's computer, open to everyone, just like Nigeria, open to everyone. But then to maintain law and order, to maintain whatsoever is happening, to maintain the constitution, the consensus rules of how you are supposed to live as a Nigerian, that's why we have the judiciary, the executive, the legislative, so that this can be handled properly. Same thing with the nodes in a particular blockchain. We need these nodes so that you can be able to check the consensus or check whether your transaction meet through all the relevant stuff that is supposed to be needed before your transaction is being validated onto the network. If not, people are going to live reckless, and then the network is going to be rowdy, and then the world's computer will eventually get scattered. But for us to maintain sanity, we need nodes so that they can be able to validate every single transaction or check the rules based on the rules that is supposed to be followed in the blockchain. It checks them, and then transactions are being propagated onto the network. So that's just why we need nodes at the end of the day. Yeah, I can't anymore shoot.
Okay, sorry, sir. As you are talking about this node and people validating the transaction, so please, I want to ask, for instance, someone running a node, so does it necessarily mean the person manually checks this transaction, or the node he set up does the mathematical checks?
Yeah, I like that. Yeah, so the person doesn't have to be the guy checking all these transactions. So what will happen is the guy who is the node, the guy who is, or the person who is running this, his own job is he is just going to set up like all the relevant things needed to be able to run it. Take for example, he sets up his the machine needed, his computer. His computer has to be connected to constant source of light. His computer has to be maybe, some will tell you 32 gig or more, 64 gig, and the rest of them. His computer is supposed to have maybe so amount of hard disks and the rest. So the person will just set up all those stuffs and just make sure that it's running. Then the person will make sure that he's running a client. So like I told you, the clients are like the rules. So the clients are like the operating system, which is being run in these nodes. So when the person is running the clients know the rules that's supposed to be followed. And then it's going to be propagating everything automatically without the person having to manually do this by himself. Good. So properly from the Ethereum website, let's understand this more. I told you guys we will be interfacing the two. So what are nodes and clients? So a node is an instance of Ethereum client software that is connected to other computers, also running Ethereum software. So each of these computers that are running different softwares or running the Ethereum clients, at the end of the day, they are interconnected with one another or connected via a peer-to-peer network. So a client is an implementation of Ethereum that verifies data against the protocol rules and keeps the network secure. That is the work of the client, because the client is the one that has all the rules. So all the rules that people will be following will be based on that client. And then the node is running the client, which is the operating system on that particular node. And then it checks and verifies all the data and the transaction, whether it follows the rules that is supposed to be followed by the protocol. So a node has to run two clients, a consensus client and an execution client. So first, an execution client, also known as an execution engine, listening to new transactions broadcasted in the network, executes them in the EVM, and holds the latest state and database of all current Ethereum data. That's what the execution client does. Then the consensus client, also known as the beacon node, implements the proof of stake consensus algorithm, which enables the network to achieve agreement based on the validated data from the executed client. That is the consensus mechanism, right? Either proof of work or proof of stake. So let's check how it works. Because we started talking about the consensus mechanism. So these are the different nodes, the different clients you can be able to run. You can choose to run your own node and the rest of them, right? But then basically that's just how nodes work. They help in maintaining the network, and then they check all the relevant rules for each of the transactions that are going to be propagated into a block. It checks all of them. So let's head over now and check the components of a transaction, what a transaction looks like, and then we head over to check out what a block looks like before we even talk about how they are being saved onto the blockchain. So transactions are cryptographically signed instructions from accounts. An account will initiate a transaction to update the state of the Ethereum network. That's what a transaction is. Then now, what is an account? Because they say an account has to cryptographically sign a transaction before it gets propagated to the network. So just of recent, we created an Ethereum wallet. And then automatically, while we created an Ethereum wallet, we automatically have an Ethereum account. So this is a simple example. So like for Farida has 0.00 USD. While I have, I think this is the base, this is my base network, right? I have about 0.83 USD. And this is mainnet. But then on my Ethereum mainnet, I have, no need, let's just leave this at base. Right? So this one is regarded as an Ethereum account. And then an Ethereum account is composed of the private key, the public key, and the rest of them to be able to help you sign transactions onto the blockchain. And then that's exactly what's happening here. Before transactions can be signed on the blockchain, we need somebody, an account, to initiate this particular transaction. So while it is being signed, the transaction is then taken, added to a block, and then the block is being propagated to the blockchain for it to be added to the chain of blocks. So the simplest transaction is transferring ETH from one account to another. What is a transaction? An Ethereum transaction refers to an action initiated by an externally owned account. So good. Now, before I go further, there are different types of accounts. So first and foremost, we talked about this normal account we created with MetaMask, right? So this account is regarded as an externally owned account because it is owned by an individual who has a wallet. So two different accounts we have. Second one will be a little bit confusing for now. Contract accounts are accounts that are smart contracts. But externally owned accounts are not smart contract-based accounts. So contract accounts are accounts that contain a piece of code. That is, they are written with code logic. But then externally owned accounts are not. They are being generated using some certain methods to be able to generate this. Right? So by an externally owned account, in other words, an account managed by a human. So any account being managed by a human being is regarded as an externally owned account, which is the same one we just created with MetaMask. So not a contract. So the contract accounts are managed by contract simply because they are smart contracts, right? So for example, if Bob sends Alice one ETH, Bob's account must be debited and Alice's must be credited. So if I send 0.1 ETH to who now? Farida. Farida is supposed to have it. It must leave my wallet and it must be credited to Farida. So this state changing action takes place within a transaction. So that's what if I send 0.1 Sepolia ETH from my account to Farida's account, automatically Farida's account is going to get updated. So with that, the state of the blockchain has moved from this state of me having initially, let me go back to, let me go to where I have money and I can be able to send, so that I will send small to her and we understand this explanation. Yeah, I think I have 0.6 ETH here, Sepolia ETH. So it's going to move from the state of me having 0.6 ETH. If I send 0.1 to her, after sending 0.1, she from having 0, she will have 0.1. So automatically the state has moved from state T to state T plus 1. That's exactly what transactions do. So transactions have the right to change the state of the blockchain. So Farida, I need you to send me your wallet address now, or your account address. And then I will trigger a transaction to send it to you. So send it in the chat. Now, this is your account transaction. It looks like this. If you go to your, just copy this guy. This is your account address. So this is regarded as your public key, your account address. If I get this key, I can be able to send money to you or send you ETH at the end of the day. It's regarded as a public address, but then generated from the public key. So for it, I just go to your wallet and copy that and send. Is Farida still on the call? You see there, just go here. Can you see this copy button? Just click it. This button that is duplicate. Click it, then come to the chat and paste. Awesome. So I just copied that, and from my wallet, I can just send some small ETH to her. So I can paste my address in here. Her address, sorry. If I paste it, it's load, and then it finally found the address and asks me how many I want to send. I just want to send 0.1 to her. And then I click continue and confirm. So you see here is pending. So currently it's going to move the state of the blockchain from me having 0.68 ETH to me having 0.5 ETH. So automatically the state has changed. So Farida from having 0, we move to having 0.1 in our wallet. With this, the state of the blockchain has changed. Can you see? And then if Farida checks her wallet now, she can be able to see that money. So Farida can be able to show us if you saw it.
Should I refresh the page or something?
You're in a different network. No. You know, I told you there are different blockchains, different networks. So currently now you're on Ethereum mainnet. So I need it to switch. So click on that arrow that is close to mainnet. Now click show test networks. Good. Click Sepolia. Can you see it? So this is just for testing. If it was supposed to be like the real money, you will have seen it in mainnet. But this one is for tests. So there's nothing you can do with this money. So that's a simple high-level overview of a simple transaction. And then we can head over to check. So you can stop sharing your screen now. So we can head over to check the different components of it. So you can see what is this contained inside the transaction from, that is who is the sender to, who is the person receiving, the signature. Because if it's not for my address, remember my wallet manages my keys and the rest. So if it's not for my wallet, automatically, if I'm not the owner of that money, I cannot be able to send it out. It's only my money I can be able to send out. So it contains all these bunch of things: a value, which is the amount I sent to her, input data, gas limits. We understand this much more better, right? And at the end of the day, this is specifically what a simple transaction looks like. So all these transactions, and then there are different types of transaction, right? Regular transaction. So a regular transaction is a transaction from one account to another. Like this one we just did now. This is regarded as a regular transaction. So I sent money from my account to Farida's account, regular. Then a contract deployment transaction. So it's a transaction without a to address where the data field is used for the contract code. So in this case, I can choose to deploy a smart contract. Remember, we said the smart contract, the blockchain is being handled by a piece of logic called smart contract, right? And the smart contract are the logics that run on the blockchain. So to be able to run, maybe I want to call a function that exists in this particular smart contract, is going to be regarded as a transaction. Or probably I'm trying to deploy a smart contract to the network. So you guys will understand all these terminologies better. Account deployment, contract deployment, and the rest of them. So I'm trying to deploy a smart contract that I want to exist on a particular network. It's also regarded as a transaction. Or I want to execute a particular function in a smart contract. It is also regarded as a transaction. So these are the different type of transactions that we have. And then depending on what transaction you are using, remember it's the world's computer. And then like I explained, when you are trying to perform any transaction on the blockchain, you have to pay for it. And that's the main use of the gas. And that's why we have Ether at the end of the day on the network, so that you can be able to use Ether to pay for gas. And then we'll understand why subsequently and how it works. What a transaction looks like. You guys can go and read to understand much better. Right, so let's head over to blocks and see. So blocks are batches of transactions, like I explained, with a hash of the previous block. Same thing I said the last time in the chain. This links blocks together in a chain because hashes are cryptographically derived from the block data. This prevents fraud because one change in any block is in history will invalidate all the following blocks, as all subsequent hashes will change and everyone running the blockchain will notice. That's the same explanation I made. All of these blocks are joined together. Every data we gather together, we hash it. and then we create a new block. We hash all the data together with the hash of the previous block. So if we create a new block, block 2, we hash it together with the previous block, block 1, and then we have one particular hash. So if any of the data changes, the hash is going to change. And if it changes, everybody will know that, oh, there's a problem on the blockchain. Oh, the hash has changed. Someone is trying to manipulate the data that we did yesterday. Someone is trying to manipulate the transactions. Someone is trying to do something that we do not understand on the network. Because all of us are trying to share one particular state. That's just what is happening. I hope there's no confusion to this level. But if there is, it is allowed. Because trust me, everyone is confused at first while learning any new technology, until when you immerse yourself into it properly before you understand what we are trying to say. So I still employ you guys today, before this class ends, to still continue reading, more reading, more reading, more reading. If not, if you don't read, the more you come to class, the more I will confuse you. And if I confuse you, if you don't read, you remain confused. But if I confuse you in here, if you go back home and you read, you will understand a lot of things that I talked about today. And then you will even see more concepts. Perfect. So let's keep going, right? We've explained transactions, and then we say transactions, before any transactions can be made, it must be made from an account. And then automatically we created an account, a wallet. A wallet creates an account and manages it for us. And then with that account, we can be able to initiate a transaction. And with that transaction, the transaction is going to get added to the block. And then the block is going to get propagated to the blockchain network. So let's proceed. Now, why blocks? Why blocks? Why blocks? Why blocks? So to ensure that all participants on the Ethereum network maintain a synchronized state and agree on precise history of the transactions, we batch transactions into block. This means dozens or hundreds of transactions are committed, agreed on, and synchronized at once. Because somebody will ask himself, why is it that if we make the transaction, it doesn't automatically get into the blockchain? Why is it that it has to be gathered in a block first by the node, by the validator or the node, and then it gets runs and then sent to the blockchain? Why? So our explanation in here is easy, and then they have given us. He said it's to ensure that all participants on the network maintain a synchronized state and agree on precise history of transactions. So instead of we agreeing that, hey, the last transaction in my own is correct, you have the correct updates, why not let's batch all of them into blocks, and then we agree based on those particular blocks, and then we ask. So the simple explanation is, if we want to rate the current workings of Mr. President or the President of Nigeria, we don't have to say every day, what did Mr. President do? Wake up today, we say, President, what did you do today? Tomorrow, what did you do? What did you do? Instead of doing that, it's stress. All we just have to do is just check based on maybe the yearly quarter. Maybe we check Q1, what did the president do in cumulative? And that's the same thing with blocks. So we gather all the different achievements and then join them in one place, in one quarter, and then present them. Likewise, blocks. We gather all the pieces of transaction and then join them in one block and then send it to the blockchain states. So this is it here. Every single transaction, let's say we have a transaction T1, T2, T3 like that. All of them are being gathered together in one single block and they're being sent. And then with that, the state of the blockchain moves from this current state, adds a new block, and then moves to another new state again. Are we clear? So how block works? To preserve the transaction history, blocks are strictly ordered. Every new block created contains a reference to its parent block. We've read that. And transactions within blocks are strictly ordered as well, except in rare cases. At any given time, all participants on the network are in agreement on the exact number and history of blocks and are working to batch the current live transaction request into the next block. So that's how block works. So every single participant on the network, which are the nodes, they try to compute what is the current update. Everybody tries to know what was the last update, what is the last block. So currently now, all the pieces of transactions on the blockchain are gathered, and then we send it to the blockchain, and then we have a block called block 1, right? We have this block called block 1, which is this block. So a new block is also big. So the work of every single node on the blockchain is to verify, hey, what is the current state of this current block? What is the max block we have now? Okay, if you check, we have processed block 1, block 2, block 3, block 4, block 5. We have processed 5 blocks. That means every blockchain is, every single node on the blockchain is supposed to have 5 consecutive blocks. So if your blockchain doesn't have 5 blocks, it means you are not correct. And it means you don't have the right state of the transactions which are entailed on the blockchain. So the idea of these blocks is to easily store this data for historical purposes so that we can be able to trace them. Is this clear? So I still employ you guys to go through a lot of reading. I can't overemphasize this enough, right? Because the class is coming to an end, and to be honest, we didn't even cover most of what we are supposed to do today. I wanted us to really talk at length to understand how this technology works. But you guys should read proper. Now, later in the day, I'm going to be sending in assignment questions, set of questions for you guys to answer. Now, I will advise you answer in your own words. Do not use ChatGPT or use Google. If you do, I will know. It's an advice. So if I send you these questions, just try as much as possible to answer it based on your own words, because I want to use them to know whether you guys, how you guys have gone far. So the questions are going to come in probably at the end of today, so that you guys are going to be reading, and then while the question comes, you try to attempt them. Or if the question comes in, you can continue reading based on what the questions are, just to give you like a proper sense of where to read from. And then you give me back your honest feedback, and then with that, I will know how far that you all have gone. So right now, I will just and take questions for the class. I think we have 9 more minutes. That should be enough to take some little bit of confusions. If I'm sure a lot of you are confused, so if you can be able to explain your own confusion, it makes it better. So the floor is yours. Yeah, Abdul Salam, we are with you.
Okay. Good morning. Okay. Can you hear me? Hello.
Yeah, we can't hear you so clear. Can you or come closer to your mic?
All right. Okay. Can you hear me clearly now?
Yeah, we can.
Okay. I said you were talking about the virtual as the class goes on, and we all know that a virtual machine is just a software that allows multiple users to access a single central processing machine, right? Now, what type of software do they use? What type of virtual machine software do they use on this platform?
Good. So that is going to be the next this thing. Can you see it here? It uses the Ethereum virtual machine. So there's what's called the EVM. Now, the Ethereum virtual machine, our next class, will go properly into it. It is where all of these stuffs are being processed, and then state changes are being made to the blockchain. So are you a Java developer, or which of the virtual machines have you worked with?
I haven't worked on anyone, but I read a lot about it.
Okay. That's good. So it's the same whole virtual machine, but this time around a virtual machine for the blockchain, or a virtual machine for the world's computer. to aid our processing.
Thank you.
Yeah, questions. Yeah, guys, question. Except you are so confused to the point that you cannot ask questions. You just want to read. Yeah, Abiola.
Oh boy, a lot to take in. Okay, so under nodes and clients, they said Ethereum is a distributed network of computers running software that can verify blocks and transaction data. But they said a software must run on the computer to turn it into an Ethereum node. So is it the software that is running on that computer that is making it a node?
Yes, actually. It is
Okay.
the software that is being run on that computer that makes it a node. And then I told you
Okay.
guys the software is called a client, which we understand clients better. There are different clients on the
Yeah.
blockchain. So once your computer is running that OS, that client, it's
Okay.
automatically set to a node.
Okay.
There's a way the
And
setup are done, Sha.
okay. Wow. Okay. So announce that transactions. They made a simple explanation there, like Ethereum transaction refers to an action initiated by an externally owned account. So which refers to that is managed by a human, not a contract. So a transaction is like a like the transaction that exists between me and you, for example, sending maybe a ETA from my own account to your account. Is that an example of a transaction, right? Abi? Uh, oh God, a lot to read. Wow. Hello, Mr. Manoah. Um, oh boy.
Hello guys, can you guys all hear me? Can you hear me?
Yes, we can hear you.
Okay, okay, sorry Mr. Adeosun. The class is almost over and Mr. Manoah is experiencing serious network challenges. So if you can drop your question on the Discord channel, we'll answer it for you from there. Is that fine?
Yeah, okay. Oh boy.
Okay, so that was the end of the class for today. Thank you guys for joining the class and enjoy the rest of your day. Bye for now.
Thank you. Yes,
You're welcome.
Guys, I'm so sorry. My network kicked me out. Can you come again with that your question?
Sorry,
Okay. So
but
what I was
okay.
okay. So what I was saying was that a transaction is, according to what I read here, like, is refers to an action that is initiated externally by an old account. Like, let's say, for example, by a human account. So an action initiated, like me transferring money from my own account to somebody else's account, is a transaction, because here they said not a contract, but managed by a human.
Yeah, so what's your confusion there?
So transaction is the only action carried by a human managed account, not a contract, right?
Yeah, for now, let's look at it as being managed by an externally owned account only. So when we go further, we explain more concept. There are some things that we teach you as just beginners. You take it before we go further. You keep understanding concepts while we go.
Okay.
But for now,
Thank
look at transactions as being handled by, originated by an externally owned account.
Okay.
Yeah.
Yeah. Thank you
So it's
very much.
12 and my time is up.
Okay,
Thank you
Mr.
very much for your time.
Manoah, thank you for the
Bye.
class. Okay, take care.
Yeah, bye guys.